maybe your stuff's located in, like an object store or something like S3, right? Your data may be just on the local machine, right? Sometimes your hardware may not actually even have much storage. Maybe it has all power and like 1 terabyte of disk. That also, I've seen strange configurations in the market like that, right? Like, so you have to pay attention to those things, because otherwise, when you run out of disk, it's going to stop your job, and then what do you do next? Infrastructure breaks all the time, partially because of things like storage, right? And finally, a lot of applications that use storage, usually you have to think about the access latency as well. So, so as your databases grow over time, you need to run batch jobs and things like that, and then you need to run a query. You need to get the data out, and then you need to put it into the algorithm, right? So there's all sorts of considerations around storage, like which databases should I use for what problem. This is actually more of a software engineering thing. It's not actually even related really to the data science workflow, but a data scientist should understand it. They don't need to manage all this stuff themselves, but they should understand what data source am I using, and is it the right one? And these are things that operations teams in IT departments should consider. Networking infrastructure. So if you think about networking infrastructure, what am I talking about here? So think about your Wi-Fi. How fast is your internet speed, right? So where is my data living? Is it in in the cloud somewhere, right? If it is it in the same region? Right? Like, so are the two computers that are talking to each other even in the same region? Are they close to each other? What you find is that sometimes you have data in one place, and then you want to run your compute in another region. Sometimes you have to copy data over, right? And so latency is a big factor. If you're going to be doing anything with either distributed training or anything where two computers have to talk to each other, maybe large-scale batch inference, then you need to think about these things. Right? So usually what a lot of people do is they download it all at once, and they put it on their cluster, right? Or on their one big machine, right? But even then, if you're doing, say, inference, right, where you're actually using an AI model as part of an application, then what are your guarantees? What is your service level agreement? What do I mean by that? That means I guarantee that all requests will finish within 5 to 10 milliseconds. Right? Sometimes customers have hard requirements, especially in things like I think the canonical use case people think of as like high frequency trading, right? Like, so there's very high requirements for that. But your networking can also affect, say, your download speed, your download speed of your data, etc. Right? Like, so in general, it affects all parts. And your data center or your cloud has a certain quality of networking. And you should know what it is, and you should know where the data lives, and how that affects your workload. So processing. One thing I'd like to point out is that GPUs are getting better. Like, I know NVIDIA released their new. They have like a new data science environment they just released, which is kind of cool. That makes it easier to interop with things like columnar data, pandas, things like that. Things that data scientists use. That being said, most basic workloads that people use are probably still running on the CPU, right? Especially actually even inference. I still in the market, I mainly see. Sometimes it's not worth it to use a GPU. Not everything's a deep learning problem, right? So it really depends on. There are trade-offs to think about when you're thinking about how you should be processing your data, where you should be running your jobs, etc. Management. So another thing people don't think about until they're hit with the GDPR penalty is governance. How what data are we using? Where do we get it from? Is the input data pure, or should I be validating that data? Right? Like, so again, as we talked about earlier, your source data matters the most, and sometimes data scientists may not always be a part of the process of actually understanding where's my data. How is it used? And is the right data being collected? So sometimes what I see companies doing is they go out and collect a bunch of data, and then they spend 6 months doing that, and then it turns out it was the wrong data. There's a lot of common mistakes because people try to jump in too fast. So model training, this is something this is everybody's favorite part. So model training is where you read the data in. You do something, you run the process called exploratory data analysis, where you maybe visualize the data. You try to understand, is this input data clean? Is it valid? Does it fit my pattern that I'm trying to recognize with my algorithm? There's a wide variety of things to consider. Data scientists run this all the time. Usually visualization is a part of your toolkit. You should be using it where you can, right? And so what do you do after you've done that process? Then you might tune your hyperparameters. Or you might, I know some people might use all the new AutoML stuff that's out there now. But either way, you need to build a model. It trains for so many epochs, and you have a trained model, and then you validate it, right? So that's your steps. But then one thing you run into is you could run into something like a sampling bias, right? Like so when you're running a training workload, it may not be on all the data, and the data may not be sampled properly. So there's a lot of tricks when it comes to understanding even how to train a model, right? Like so how does that relate to infrastructure? Well, when you download data on your local machine, what are you doing? You're collecting all that data, and then that's the data you're going to run your training job on. Well, it turns out, did you download the right data? Or is it a representative sample? And then from there, right, if it's a distributed job, then your networking and everything kind of affects the outcome of this, right? So again, think about what am I feeding it? How do I tune it? So if you're doing hyperparameter search, that's going to cost you usually, if you're doing deep learning, it's going to cost you a lot of GPUs, right? Like so the bulk of the GPU compute, say at Google, for example, that's actually a lot of that is actually just hyperparameter search. So you spend a lot of time just finding the right hyperparameters, right? So you may do this at some large scale or what have you, or you may just maybe training random forest. Maybe you don't need to do very much tuning. It really depends on what your workload is and what your algorithm is when you're thinking about model training. There's different architectures. So you might have like multi-GPU systems that are interconnected to each other. Maybe you're using InfiniBand. Maybe you're using Ethernet. There's a wide variety of different configurations to consider there. And then what you might use is like a remote file system like HDFS or Cluster. This is very common in say HPC workloads, for example. Hybrid cloud. So you might have your some of your data on-prem, some of it in the cloud. Maybe your data is stored in a little bit of S3, and then it's stored. It might be mixed on-prem as well. Right? Like so, very common. This is when you're training. This is important for your batch inference, and it's also important for when you're training your models as well. So GPU training, CPU inference. Again, there's the point of this is there's a bunch of different configurations to think of when you're deploying models, right? Like so, what are you? So again, just think about this. Like how is my application going to be used? Am I building a recommender engine, for example? If you're building a recommender engine. You may have to do a lot of batch workloads in the background to surface the recommendations for users. Like for example, LinkedIn. So when you get recommended friends, what they actually do is they run a batch job every 24 hours that computes all the recommendations and then sorts them from the database. Right? So that will involve usually some form of distributed compute. Some it's CPUs, some it's GPUs. Right? So there's a lot of common workloads that you should be thinking about, and it does relate to your algorithm. Right? Especially when you start dealing with any large amount of data. And when I say large, that could just be something that doesn't fit on your laptop. It may be something that could be petabytes, right? So I've seen a wide variety of configurations. So what do we think about with model training then? So distributed. So this could also be you could replace Spark here with say Orvad, for example. Orvad's the new toolkit by Uber that does distributed training of deep learning models using Keras, TensorFlow, etc. So what do? You split your data up. You decompose the job into several tasks. Maybe running one model per machine, and then you're running here something called data parallel workloads, right? Like so you're partitioning your data, and you're on each replica of a model. You're doing an update, and you're doing this for a while across the whole cluster. So here's a more complicated example of batch training with Spark, where again you do the same thing. You have a scheduler of some kind. It figures out how to partition the tasks. This is what it looks like when you have something like a resource manager. Something a lot of people don't realize is when you need to schedule things on a cluster, you're probably sharing that cluster. So what does that mean exactly? You might be scheduling things on maybe your company has a total of 10 GPUs. And one thing I find is that people aren't using those GPUs effectively. So and that affects their training time. That just affects the data scientist's productivity, right? Like so again, just think about how your data is partitioned, who has access to what cluster, and understand that a resource scheduler is in there somewhere, and that your data will need to be